Number 19 for my practice problem test. There's an equation passing through points -5, 8 and 1, -1 and points, and they want us to write it in point slope form.
In point slope form. Okay, so whenever I see that, I like to kind of put some things on the paper. It turns out that, like, as humans, we process 80% of our knowledge through our eyes if we're visual. So I like to always just try to put things down here so that I can remember exactly what I'm going for, or so that I don't have to remember what I'm going for. I can just see what that I'm going for. So at the very end of this problem, I will know I am done when I get something that looks like this. All right, what are we thinking?
I was thinking of They want us to write, okay. I don't really know where to start, kind of. I was thinking that if it's an equation and a line is passing through these points, we can see how we got from one point to the other one.
Okay.
We don't
That's
really
getting a
know.
lot for me to keep in my head. Can we make a picture?
Yep.
Okay. I'm a big fan of the picture. So nice little reference picture up here. -1, 2, 3, 4, 5, 8, 1, 2, 3, 4, 5, 6, 7, 8 point going until 1, -1, 1, -1 here. So this is what we're looking for, right?
Yep.
Okay. So what can we do from here?
We can see how you got from one point to another. How many steps it took. So from -5 to 1.
Mm-hmm.
So from
How do we do that?
From -5 to 1, you had to go up 7.
So here's a time where I would like us to start, especially as we're prepping for the test. Good idea with starting with the intuition, and we could kind of do some counting. But by now, we also want to make sure that we're kind of pushing to some equations that can help capture our intuition without us having to remember all of the details. Because the longer we take to solve a problem, the more chances we have for error, right?
Right.
So if we're going from -5 to 1, we absolutely could just count all those. How many would that be?
6.
Good. So as a fallback, if you feel stuck on a problem, draw a picture, count some things out. Great way to help keep us from falling out. In order to kind of help with the speed of things, keep in mind we could also notice that by now, if all I'm looking for is the difference, then that is all we have to do. The slope is going to have something to do with run, which is actually the bottom, and the run is just the difference between these two things. It'd be 1 minus -5.
1 minus -5.
Do you want to do it the other way? We can do it the other way. Let's do it the other way. I'll show you it actually doesn't matter. Okay, so you want to do it as the difference here. We'll do -5 minus 1.
No, we could have did it the first way.
Okay, I'll do both way. We'll push our boundaries. What about the y values? What's the difference between the first y value and the second y value?
So it's going to be y minus 8.
Okay, so first y value is
8.
And the second one is
-1.
good. So 8 minus -1.
Okay, hold on.
So this tells me that my slope is going to go 9 over -6. In other words, you're going to go down 9 over 6 or left 6 up 9. Rachel, what do you think?
Don't you, when you write this rise over run, you do y2 minus y1 over x2 minus x1?
Okay, good question. So what I want to show you is it actually doesn't matter. I do it as one way to kind of make everything nice and concentrated, but it actually doesn't matter. Let's treat it like this point, Rachel. We just did it where we treated this one as y1 and this one as, or sorry, 0.1 and this one's 0.2, right? Okay, let's imagine we switched it now and we made this one 0.2 and we made this one 0.1, almost like we're traveling back in time, right?
Mm-hmm.
It actually doesn't matter. Let's take a look. We'll do then -1 minus 8, which is the way you might have felt like we needed to have it, right?
Yeah.
And then we'll do -1 minus -5, right?
Mm-hmm.
And let's take a look at what happens. So -1 minus 8 would be -9. -1 minus a -5 would be, oh, hold on. I think I messed something up. This is a positive one now, isn't it? That's a positive one. There we go. Sorry about that. So 1 minus a -5 would have been 6, right?
Mm-hmm.
Okay. It's the same thing.
Oh, okay.
So long as you choose any 2 points, they have to have this common ratio. The reason it's the same thing is because in this situation here, you had the negative talking about the rise. In other words, you were looking at it as I was dropping down as I was going a positive x direction. But we could have
Mhm.
looked at it where I said for every negative x direction I go of 6, if I go backwards 6, I just have to go up 9. It's the same rise over run. It's just which direction do you want to travel?
Oh, okay. Okay, thank you.
So long as whatever you call 0.1, whatever you
Mhm.
call 0.2 doesn't stay any different, like, and you're just talking about going from 0.1 to 0.2 or 0.2 to 0.1, it doesn't matter. The change in your y's, the change in your x's, your rise, your run, so long as you have that thing solid, everything else has to work out where it works out.
Okay.
Okay, so Mikey, let's go back to you. What do we want to do from here? I've got my slope, right?
Okay. You did it 2 different ways.
So all I found here is that you can actually look at it in terms of going from one point to the other or the other point to the first. It doesn't actually matter. There's nothing that says the first point has to be the one on the left. So once we have that slope, what can we do from there?
You can do the opposite.
Why would we do the opposite?
Because you're trying to find out. Wait, why do we do that? You're trying to find out the other equation of it. So
What other equation?
you're trying to find out the line that it's going through.
Sure. So we're trying to find this, right?
Right. Yeah, he can help.
Javari has an idea. Do you mind if we throw it over to him, see if there's an idea there?
Yep.
What do you got, Javari?
Will you plug it into M,
Plug it into what?
the slope,
The slope where?
where it says, like, would you use the equation, like, put everything?
Okay, so you want to just take this.
Yeah.
Okay, so it's going to be -9/6 for M. Is there anything else we could plug in?
Yeah, the X and Y values.
Okay, for which ones do you want to choose?
-5 and 1.
You want to choose this one?
Yeah.
Okay, as it turns out, it's actually no different if you choose the other one.
Okay.
Kind of crazy. So, and I'll show you why this is to kind of tie it all in a moment. So we have x minus x1, which you want to make the -5. That's fine with me. And then over here you have y minus y1, which is your 8. And sure enough, this is going to be a point slope form of that. This is great. You could simplify it up a little bit. We can make this positive and get rid of that. But this is absolutely done. This one's slope is exactly what we found out. Then we can just use its points and its slopes to get the point slope form. Does that make sense?
Yeah.
Okay. I'm actually going to add a little bit more onto this one. So here's the thing I kind of want to do for everybody as a little bit of a reminder. When you're talking about all lines except for the vertical one, all other lines that have a slope, really the way that we can think about these is saying, I have some kind of point, I'm going to be traveling a direction up from there, and any point that I go to, any other point, any x comma y point that I get at, has to follow a couple of interesting properties. Like if I start here and I say, okay, I'm going to start at some kind of x1, y1, all I know is if I am on a line, that means I have to have a slope that's consistent, a slope that's constant. So that just means that m has to be some kind of number and has to be the exact same number for any of these points. So that's where you get your idea of saying it's going to be the difference in your height to rise. And the difference there literally meaning subtraction, difference in the heights, y minus y1, over x minus x1. And as it turns out, slope has to be the same for all of these points. So you could actually connect this to any 2 points, any y2 minus y1 or x2 minus x1. And this is where you get a whole lot of play and wiggle room, because we could have chosen this is our starting point, this is our starting point. We could have found our slope one way, we could have found our slope another way. So long as we're talking about it in terms of a story, it has to always be true. So I'll leave this one actually as a little bit of a fun riddle for you all to play around with. We've already found out why the slopes are the same. Try typing in the numbers, and what you're going to see is that they look different. But if you go through the process of actually kind of simplifying it out and getting rid of some of those parentheses, they're all going to turn out to be the exact same thing. Because the story literally says, if I start at a point and I go up a certain amount and over a certain amount in a common ratio, then I have to always end up on my line. And if I go backwards, I will always still end up on my line. So it doesn't actually matter.